Acceleration analysis. Acceleration analysis. The rate of change of velocity with respect to time is known as acceleration, and it acts in the direction of the change in velocity. Tangential and centripetal acceleration. The rate of change of velocity in the tangential direction of the motion is known as tangential acceleration. It is equal to mu alpha, which is equal to dv by dt. The rate of change of velocity towards the center of rotation is known as centripetal or radial acceleration. AC is equal to V square by R is equal to omega square R. The tangential component of acceleration occurs due to angular acceleration of the link. The acceleration of the intermediate points on the links can be obtained by dividing the acceleration vector in the same ratio as the points divides the link. Coriolis acceleration components. Let omega angular velocity of the link, alpha angular acceleration of the link, v linear velocity of the slider on the link, f linear acceleration of the slider on the link, r radial distance of point p on slider, analytical formulations, acceleration of p along ar, acceleration of slider minus centrifugal accelerations, which is equal to f minus omega square r, acceleration of p perpendicular to ar, Coriolis acceleration plus tangential acceleration is equal to A perpendicular AR is equal to 2 omega B plus R alpha. Point to remember, the component 2 omega B is uniquely defined as the Coriolis acceleration component. Directional sign rule. The Coriolis component is positive if the link AR rotate clockwise and the slider moves radially outward. Or if the links rotate counterclockwise and the slider moves radially inwards, otherwise it is negative. The precise direction of the Coriolis component is obtained by rotating the radial velocity vector v through 90 degrees in the direction of rotation of the link. Klein's constructions. In Klein's construction, both the velocity and acceleration diagram are structurally integrated directly onto the configuration diagram itself. The line representing the crank in the configuration diagram also directly represents the absolute velocity and acceleration component of its moving end. Ratio of equivalence AB by ON is equal to ATVA by AM, A by OA, ATN, VA by NM, omega square VA by OA is equal to VB by OP is equal to VBA by AP is equal to omega crank. Some other important points. Acceleration images. Highly efficient tool to determine the absolute acceleration of any offset points located on the kinematic links. The acceleration image of a given link is constructed using the identical geometry ratio manner as a velocity image. Relative coincident acceleration. The acceleration of a specific point on a link relative to a completely coincident point on an interesting moving link is computed as a vector sum of absolute acceleration of the coincident point, relative acceleration of the tangent point with respect to the coincident point, the corresponding Coriolis acceleration component,